Okay, we are. Hey, good to see you here, Adam. How's it going? So I just sent out the announcements to everybody. So see someone in the chat right there. Are you working on the project? Are you working on the 474? You guys get to pick what I do. I've got the project up right now for 201. So if you're asked, if you have questions, what I'll probably do is I'll do very similar questions because I won't try to do the exact project. I'll do questions similar to it and kind of talk about, hey, let's look at this data and see what this says. And let's look at this data and see what it says. So feel free to be like, what is question this asking? And then we'll take a look at the question. Hey, what's up, Nacho Bear? Ask any question you have related to the project, related to whatever you're doing. I can go to assignments, wherever you like. Nacho Bear, so good to have you. So whatever you have questions on, feel free to ask. Just type it in the chat. One thing we want to do first is I'm going to hop over to some jump data. I'm going to open a different data set. Please make this clear. I wish I could put a disclaimer at the bottom of this video that I'm not going to work with the haircut data, but everything I'm doing project, ask a question in the chat. Be like, question number 2, question number 3, any of those. Project, please ask away. Starting project tonight if I have a question. And anyone who's got questions on it right now, and in this video, I'm going to try to do as many similar questions as I can to the project. So, hey, Sine, good to see you here. So good to see everybody here. Ask those questions. One of the first things the project asks you to do, this is not the project data, this is different project data. Can I use PowerPoint to display my project? As long as you're one of mine, right, Preston? I would assume so. Well, this is open to everybody right now. But if it is doing what we want, if you could take everything in the PowerPoint, I'm wondering if Canvas will let us do it. Put everything you have in the PowerPoint in a Word document, and I will, if you email me your PowerPoint, and probably best to do it in Word. Best to do it in Word because Canvas takes words, and that's how we can check for plagiarism and stuff. When we type out the answers to the questions, can we include which questions? Don't include the question numbers. Don't include the question numbers. You can do it while you're writing it out, but in the end, we'll want it to look like a report, and we'll want it to look with no question numbers. It's so good to have so many people here right now. If you notice right here, what's really great is we give an example here at the end, and I highlighted this yesterday. So this is an example of what you might turn in. And there will be an executive summary at the start, which is going to do 3 things. 1, it's going to go over what we're doing, collecting data on tips for haircuts. How many people did we take? What variables did we collect? 2, it's going to talk about the key findings. And that's where you really want to mention numbers. And so the key findings part of it is where you go into all the numbers. So right up here at the start of your report, you have a good 4 to 6 sentence executive summary. Doing 1, it introduces the reader to the report, makes it clear what we're trying to research here. 2, it tells them the key findings in the report, like think of all your big key findings and give the numbers. Give the numbers. 3, it's going to make a decision. It's going to be like, from this we should do blank, we should do blank, we should do blank. The chapter 5 part 2 was pretty hard, but I got great news. 1, please know chapter 5, it's a very important chapter for the test and later on in the class. But 2, chapter 6, people were acing today. People were getting a head start on chapter 6, and wow, so many people today with chapter 6 were making great grades. I was like, did you make 100? And they're like, yeah. They're like, wait. I don't know. I was really proud of them. They made 100. Great job. And I love seeing it when you guys get hundreds because I know when you see that 100 on the screen, there's like the yeah. And so quote a lot of your numbers. Like I'll give an example right here. I'm going to do a very similar problem to number 5. So number 5 has you do side-by-side box plots. So side-by-side box plots mean we need a quantitative y and a categorical x. So let's go ahead and compare GPAs of males and females. So this is how to do number 5, but a totally different question. I know chapter 6 is like the relief from chapter 5. So, Adam, you're totally right. Quote the numbers. Alexandra, thank you so much. 1,000 points, Alexandra, right there. Let's go right here and let's see if gender explains. You see how I'm going to put gender in the X? I want to see if gender explains somebody's high school GPA. Now, this is going to give us side-by-side box plots because gender is categorical, that's the X variable, and then the quantitative variable is Y. So we're going to get side-by-side box plots here as soon as I go up here and I click the quantiles. Now, you don't need the point jitter. My video shows the point jitter. I'm going to expand the window here just because I've got that blank space. If I were to take a screenshot, I'd want it to be pretty well presented. So rather than, you can think of like let's do the 3 different types of screenshots. Like that'd be horrible. Bad screenshot. Good screenshot, acceptable, and then this right here. And you do need the quantiles. Any number you mention, you need to put in the report. So if you have these numbers being mentioned throughout your report, make sure to put those numbers in your report. What do you notice right here? What is the key thing you notice? Well, one, we've got some outliers. These are kind of skewed distributions. I see males down here with some extreme outliers. If you want to have some fun, you can highlight the point, and you can go here, and you can go to rows, and go to markers. You could put a little star on that person. You go to rows, you go to colors, and you'd be like, uh-oh, that individual down there is an extreme outlier. You don't have to do those types of things. Once again, that's just me being me. But you could be like, there was a male in the survey who had a 0.1 GPA. And what is the IQR considered large? Well, first off, we need to compute these IQRs. Very good question. If you notice, males, you can see it visually here, have a larger IQR than females. I'm going to compare the medians, and look, we get the numbers hovering over it. I'm going to compare the medians and the IQRs for males and females. The median for females was 3.9, which represents the 50th percentile of females' GPAs, whereas the males' median was 3.7, which represents the 50th percentile of male GPAs. There's a 0.2 difference between male and female's median GPAs. Notice how I found the difference to compare them? Key stuff right there. Next, we want to compare the IQRs, and this one you're going to have to pull out a calculator on. I wonder, I wish we could add in the IQR. Oh, such a bummer. I wish we could add in the IQR, but we can't. There are ways, but not easy ways. So we're going to find the IQR, which is Q3 minus Q1. So we're going to go 1.0125 minus 3.7, and that is the IQR for females. Females' IQR has a range, or the middle 50% of females has a range of 0.3125 GPA points, whereas the IQR for males, the middle 50% of males' GPAs has a range of 0.5075. And I think, so females' GPAs are basically 0.3 and males' GPAs are 0.5. So the males have a much larger, hey, Julio, good to see you. The males have a much larger range to the middle 50%. You can really see that in the box plot right here. Look at this box. It's like that large. That is the IQR visually. And the females' box plot is this right here. So there is a much larger spread to the females' middle 50% of the data. Just comparing those numbers, contrasting them, making sure that the IQR is known as the range of the middle 50%. That's what it is, will help you prepare for the test. So you need to say things like the range of the middle 50% for females goes from 3.7 to 4.0125, these two numbers here, and would have a value of 0.3125. Whereas the males have an IQR, middle 50% range, of 3.3925 to 3.9, and this was evaluated to be 0.5075 GPA points. Yes, Dylan, it is. We got that chat latency down. Hopefully you're like, I just typed that, and that's what we like. So thank you, Dylan, for all your help with this. We want to make this as awesome as possible. What other questions are there? This is basically number 5. I'm not doing number 5, but I'm kind of doing number 5 because if we can analyze side-by-side box plots, we are on track. Who has a question? Be like, Brian, I'm stuck on this. I can't find the haircut data. Let's find that haircut data. So to find the haircut data, we're going to go to the Stat 201 webpage. We're going to decrease font here. Oh, there we go. You want to go to projects and go to project 1. I'm currently on that page. So when you click project 1, you will go to this page. And here is the haircut data. I'm sorry it looks weird. It's got the click to download button, but that's because you can't upload a jump file to WordPress sites. It's like, what is this file? And I was like, it's a jump file. So this is actually on my UTK drive, my, OneDrive or whatever. Kind of confused with question number. Oh, we said we were going to do the pivot chart today. Cool. Preston, great question. Let's do the pivot. Nacho Bear, tell me if you still can't find it. I'm going to put this link in the chat. Here is the link in the chat, Nacho Bear. So there's the link in the chat. Right-click it, open new window, and that will bring you to this page. And on this page, it is this button right here to download the jump data. If it's not downloading properly, you might not have jump, but if you know you have jump, if you can open jump and see the stuff I'm kind of seeing, then you should be able to, just if my nose right there, you should be able to open the data right here. You thought, yeah, I know. I'm so sorry. That's why I put the click to download thing on it. I'm so sorry it doesn't. They literally changed this last semester. There weren't these download buttons, but I can't. I tried for like 30 minutes and I can't make it. Multiple people have said, like, where's the data? And I'm like, it's in the middle of it. That's why I wrote click. But no, don't worry. You are not the first person to be like, I didn't see it there. Not the first person. I know it is a little bit confusing. Can I do the work on Pages and save it to Word document? Yes, you can. You can definitely do it on Pages and switch it over to Word document. Let's hop over to question number 6. So what we need to do is we need to take our data and export it from Jump. So I'm doing it on the PC version. On the PC version, there is no export, and there's a video for both of these. On the Mac, you'll go to File, Export. On a PC, you'll go to File, Save As. Remember, there's a video for the Mac, so if you're like, how do I do it on a Mac? There's a video for the Mac, but you'll see File, Export, and then you'll see the option. Now I'm going to go down here, and I'm going to go to Excel. If you notice, I'm clicking on the Excel link right there. It's the second one. I've done this a few times. And then I'm just going to save it. I might have already done this before. I have. And it's going to open it, and we do it. Just click yes to the things it tells you. So now we are opening the data inside of Excel. We are opening the data inside of Excel. With this data opened inside of Excel, we're going to do the following. We're going to click Control A. Don't click anywhere yet. Just click Control A. And then we're going to go to Insert, and we're going to go to Pivot Table. Next, we're going to click OK, and we now have the start of a pivot table. Let's watch that again. Remember, you can always rewind or ask me in the chat, can you slow down? I'm open to both those right here. So let's go back and find our mouse. We're going to go right here. We're going to pretend we just opened up the file. We're going to click Control or Command on a Mac, Command A on a Mac, or Control A on a PC. With that clicked, we're going to go up here to Insert and click this button here that says Pivot Table. Now we're going to scroll down and just click OK. That's because we've already selected our data and we're going to open this in a new worksheet. All the options we have are already input for us. Now that we're here, we're good to go. I'm going to expand this out just a little bit so we can see what's going on. We wouldn't usually do something this ridiculous, but make sure you've got your resolutions probably set to decent 720p quality, and you'll be able to see what we have right here. So in this one, I'm not doing your exact project, but I'm going to do something very, very similar. You want to analyze, let's look right here. Let's say somebody's age. Age is quantitative, just like tip. There's a button that appears way over here. It'll look like an eye on a Mac, and if you click it on the Mac, it'll automatically bring you to where you need to go. This video will be available later. Feel free to check it out or leave a question before you go, and I'll answer it also. That does say value field settings. It's hard to see from this angle. And now we're going to go to average. So we're just going to double click average. On the Mac, it'll be a little eye over here. There'll be a little eye. You'll just double click it, and it'll bring you to the value field setting. So now we're displaying the average age. Let's zoom in on that. That is the average age of UT students. Yours might be average tip or something like that. Now we're going to go here, and we're going to put born in Tennessee right here, and then we're going to put distance from campus right here. So we've put our variables into the rows and the columns, and I'm kind of blocking it a little bit here. I'm going to step out of the way. We're in the dig dug today. So we've got it. Can you explain? Yes. We'll go back to the box plots here in a second. And so we have our data in the pivot chart. Now here's the important thing. We can change the decimals. The project now says 1 or 2 decimals is fine. I'm going to click this. I'm going to click that right there. Then I'm going to hold Shift. And with holding Shift, I'm going to click this. I'm going to let go of everything now. So I've just selected all my data. I'm going to go here to Home, and here's the Delete the Decimal button. Now I have it down to 2 decimals. I could do 1, project says 1 is fine, or 2. So this is just me doing kind of my own pivot chart right here. And now with clicking inside of here, I'm going to go to Analyze, Pivot Chart. The first option is the one we want, and wow, that's something going on right there. This one right here is not properly ordered. Yours is probably properly ordered. Hint, hint, hint. This step I'm doing is something you won't have to do. So hopefully someone's listening. I wish I could put up a thing like, you do not have to do this. I want to make these properly ordered right here because it's going to make a little more sense. You have to click right on that. And so we have this. How do you know if there's a relation between two variables by looking at Mosaic Plot and consider? Yes, that is. We're going to do box plots again next. And then Campbell, you got the next question. And when you look at this right here, our pivot chart is almost done. I'm not going to do these last, well, I'm going to put the things here for them. I use this layout, and then I add in my last axis title, and we have now made, I might have to decrease font size because that's being a little crazy right there. Ooh, you don't want it to look like that. You want to make sure the pivot chart looks acceptable. And I probably, oops, there we go. I think this looks pretty good. Let me see. I like this now. I haven't filled out what the things are called, but if you notice, what's the key thing you notice right here? Wow, this is kind of cool. I didn't expect this to turn out this way, but where do you notice the key difference in this chart? Where do you notice delete complete 1 to 2 decimals? You can do 2 because it's money, or you can do 1. So 1 to 2 decimals. Probably 2. I updated the instructions today because someone was like, why can't we use 2 if it's money? And I was like, yep, you can use 2. And so the new instructions, but it still says you can do 1 because we don't want to make people think they did anything wrong. So the instructions now say you can use 1 or 2 decimals. Yeah, Rand, we'll do that here. You're a third in line, and you got it. Can instructions ask for 1 decimal, I believe? I changed it today. Sorry. Because multiple people had said since it's money, can we do 2 decimals? And don't worry, nothing. If you are working from the original project, there's only clarity added or exceptions made. So when we update a project, we only add clarity because people were saying, why can't we use 2 decimals? And if you notice right here, round all values, and then I said after it, either will be accepted. So just so no one would worry, because we had a lot of people saying, what if we do it to 2 decimals? And everyone was like, it's all right. And then we don't want people to think that if they did 1 decimal, be counted wrong. So that's as much clarity as we can give in the project instructions. And if you did to 1 decimal, you're fine. If you do to 2 decimals, you're fine also. You'll get total credit right here. So you will never see any major change to the project that we wouldn't announce, but we might just change a little bit of the wording to make it clear that we will accept 1 or 2 decimals. So it used to just say round all to 1, but now it says 1 or 2. And does that make sense right there? So we just try to maybe add more clarity. Awesome. Good stuff. And we've kind of done it. We've done a really good, but what do you guys notice? I need someone to tell me. We got to get on this next question. So we got to figure out, what do we notice about the relationship with these variables? Generally speaking, whether someone is born in Tennessee or not born in Tennessee is what, unless you look where. What do you notice? What do you notice about the people right here? And where do you see the big differences? Like, what is the big takeaway from this graphic? Like, I've got a big takeaway from this graphic. There's a few things to learn from this graphic. And what would you learn from it? I see only a few things. There's something that jumps out majorly. There's like one thing that jumps out ridiculously. Anyone have any ideas? This is what we would need to write about. We'd need to be like, well, I noticed this with this graphic, that people here are this, and people here are this. It's really the what. Someone's got to say in the chat for 10,000 points. We need to know what is going on with this graphic right here, because this is what we'd write about in our report. And of course, we were going to put in the 30-plus minute drive, 10,000 points right there. It's definitely that the people who are 30-plus minute drive who are not from Tennessee. Oh, be careful. Great answer right there. But this is not quite a histogram. So this is kind of a bar chart representing the averages for each group, and each bar represents kind of the average. So it's a pivot chart, technically speaking, but great answer right there. Campbell 3, another 10,002. But the big thing we notice right here is that the 30-plus minute drive individuals, and I want you to think about this, if they're not from Tennessee and they're a 30-plus minute drive, they're probably, they are older. That's what the data says. The average age of the individuals who are 30-plus minute drive and they are not from Tennessee are 33, basically 33. You'll notice that the people who are really far away, who are from Tennessee, are not that old. 20, but relatively speaking compared to 33. Then also we have the 10 to 30 minute drive. They're older also. But the on-campus people are virtually identical. Almost in all cases, it doesn't matter if someone's from Tennessee or not Tennessee, the ages are pretty similar, till we get to the larger drives. When we look at the larger drives, there's a big difference between the people's ages. The 10 to 30 minute drive individuals had a 22 average for the people who are not from Tennessee and a 20.51 average for the people who are from Tennessee. Meanwhile, we see the biggest difference here for the people who are 30 plus minutes away. The average age for the people who are not from Tennessee is 33.14, where for those who are from Tennessee is 20.41. That's the kind of stuff. Independent, yes, I like that right there. It's pretty independent. There's no real relationship between the variables until we get to, that's a great word right there, Heidi, 10,000 points. We're throwing big points today. You are correct. It's pretty independent till you get to that 30-plus minute drive. There's not really an association between the variables. Be careful. We wouldn't say correlation. That's only for QQ, quantitative, and this is categorical stuff. But great answers right there. Keep them coming in the chat. I really appreciate all those answers. I think someone wanted us to go back to box plots here. I'm going to do another box plot example, and then I think we're doing Mosaic, and then we're going to do a 474, I think. So let's hop over here and look at some box plots again. Now, to do side-by-side box plots, I need a blank variable and a blank variable. And this has been on the test. I need one this variable type and one this variable type. This has been on the test before. Who can tell me in the chat for another 10,000 points, big points today during this, since we have so few people, we'll get out the big points. What do I need? I need one type of this variable and one type of this variable for side-by-side box plots. I need one this variable and one this variable. So we're going to do side-by-side box plots again. Let's go here. One this variable and one this variable. Quantitative and categorical, you're right. Both of you right there. You both get the points. You got it. Let's go right here and see if somebody has broken a bone. And let's see right here, high school GPA. So what do you think? The people who have broken a bone, do you think they have higher GPAs? Who knows? Let's find out. So we're going to make a box plot by going here and going to quantiles. We're going to make the graphic look awesome. Oh, there's our person with I highlighted this person earlier just so people are wondering. I'm going to remove it. So you're like, how did you do that? They are now normal. They still have a 0.1 GPA and they have broken a bone. So that's not fun. So great job, all those answers in the chat. And what do you notice about this? This is about as identical as, look at the numbers. Aside from it's like you copied it's like you took this and copied it right here. Look at the 10th percentile, the Q1, the median, the Q3, the 90%, which we don't really talk about much, and the maximum. The only difference is among the minimums. This would be super not interesting to write a report on, but we get the side-by-side box plots here, and we would say something like in our report, analyzing the high school GPA of people who have broken a bone versus those who have not broken a bone showed us that there are very few differences. Since high school GPA is so skewed, you see kind of there's these outliers and there's like a left skew to it. You could confirm this. I'm just going to confirm that it's left skew by going here to high school GPA. And it's got skew and outliers. I guess a little bit of a left skew. We're going to do the technical check on it. This is not something you would be expected to do, but we're going to technically check it by checking skewness. Negative, probably. Yeah, it's negative skew. It is left skew. Don't do that in your report. You can if you want. Doesn't hurt to put something extra. But since it's left to the low, it's a negative skew, probably due to these outliers. If you notice all those outliers right there, you can make the box plot however big you want. You can resize graphics, whatever you think looks nice. But there is a left skew here, and there are extreme outliers, which means we would compare the medians. Comparing the medians for both groups, there is no difference. Both groups had a 50th percentile of GPAs of 3.8. Comparing the IQRs for both groups, there are no differences. Both groups had a range to the middle 50% of 0.5, found by taking 4 minus 3.5. So that's kind of, if you notice, when I said the IQR, here's the bad report. I'm going to give you an example of bad report here. The median for both groups is 3.8. The IQR for both groups is 0.5. That's not enough. The IQR, which represents the middle 50% of people's GPAs, has a range going from 3.5 to 4. This gives us an IQR of 0.5. Or you could say the IQR of 0.5 represents the range of the middle 50% of GPAs, ranging from Q1, 3.5, to Q3, 4. It was 4 right there. So if you hear the difference between like the C answer and the A answer, the C answer just gives the numbers. The A answer gives the context. And I probably should have said GPA points or something like that. There's always a way to make it better, but we kind of try to keep it like short, sweet, and give like the exact information. The bad answer on the median would be something like the median for both groups is 3.8. We should say something like the median represents the 50th percentile of people's GPAs. Both groups had a 50th percentile of 3.8. There is no difference between the medians of the groups. Should we use numbers when answering the questions, or in this case, say married, use their card more often? Use the numbers. And that's, I think you're talking about 4B or so. And I think the Mosaic Plot was next. Great lead in right there. Nice questions. Great job. I'm so glad to have you guys and gals here. Let's hop right here. Let's do a Mosaic Plot. So we're going to go over here to the fit y by x, and then we're going to go right here. We're going to see, can gender explain if somebody has broken a bone? So you notice I put gender in the x and broken a bone in the y. Both are categorical, which means we get a Mosaic Plot and contingency table. I'm going to go right here and delete the things I don't need. And I'm just removing, if you saw it, I removed these two because we won't be talking about those. I'm going to go up here on the Mac. It'll always be showing. On the PC, you have to click the bar. I'm going to click the selection tool. I'm going to click this one time. I'm going to let go of it. Make sure you let go. Don't click and drag to start. And then I'm going to drag, and I'm going to go right here to that bar. Either of these blue bars is all right, but I really like that little one that's hard to get. It's like the secret, and it puts it right there. That's where I want to see it. A lot of people... and it's a lot of people putting it all the way over here. Oh, no. Look at all this blank space. No, I'm a perfectionist. Oh, no, too much blank space. If you put it here, not the end of the world. If you put it here, fantastico. That's the secret one. We got it. We got the secret. Okay, awesome. So that's just, good graphical presentation is important. And this right here is going to be our graphic that we're going to use for our report. So always use snipping tool or Command-Shift-4. Really great when you're sending people messages and emails too. You can just take a picture of your screen, send it right over. Just be like, here you go. Here's what I want you to see. This is what's on my screen right now. And you just quick way to send it. So when we drop this into our report, oh, look, we already got, oh, wait, is that the one I did? Oh, I did that during class, I think. I was like, here's a one for you. Just the count and the row percentage. Now, here's the thing. It's all right if you have the other ones. It's all right. You don't need the other ones. They won't be necessary, but it is all right to have them. Now, if you've already made this graphic, please look and make sure this number down here is 100 something. If you made this graphic, make sure it has 100 something, which is the last two of your UTID. Make sure it doesn't say like mine's not the same date as yours, but make sure it doesn't say something like this. I want someone to tell me, and this would kind of be for 4B, what percent of females have broken a bone? What percent of females have broken a bone? What percent of females have broken a bone? You can just round it. I want for 1,000 points in the chat. Who can tell me what percent of females have broken a bone? Does anyone know what percent of females have broken a bone? So is median and IQR the middle? Median is the 50th percentile. IQR is the range of the middle 50%. Everyone in the chat getting the answer right. Anna! So good to see you. So good to see the people in the chat. Got some classic people in here from previous semesters. You are right. You get 10,000 points right there. I think, wait, are you your last semester, right, Anna? I think. Am I correct? I think. Am I just delusional? So, yes. So good to have you here. So, yeah, awesome. We got some new things this semester. We got a speedrun thing. It's so cool. Here, let me see here. It should bring it up. I don't think I have the speedrun button working properly right now. I have to fix it after this. Oh, that's so awesome. No, that's so great. Like, we love you guys, and we're glad that you've enjoyed this class. We've got a speedrun thing. I don't think it's going to do the thing, but it goes over here, and we have a speedrun thing now. And there, the speedrun there, it appeared in the window. So I do speed runs, and we start the clock, and we're just like, okay, let's go right here. Let's get the thing done, and then we do it. It's so much fun. Yeah. So I have to fix it after teaching today. So that's one of our new things. Awesome. And look at that. Getting the answer right for how to do it. Amazing job. So we see right here that we have the data, and as pointed out from everyone in the chat, that the percent of females who have broken a bone is 40.83%, as opposed to 50.03%. So males, the probability of a male breaking a bone was 18% higher than the probability of a female breaking a bone. We actually see this difference right here. If you notice, space pen does not look good on that. If you notice this difference, we'll go add in a green pen here. Green pen. That's the difference we're observing, which would tell us that there probably is something going on. You might have gone over this, but are about to please remember number 5 on the project. Yeah, is it the side-by-side box plots? We can go back to that here, and then I might do some 474 for a half moment. I might do that more at the end, too. Does this help? Does everyone understand kind of what we're getting at here? I want to mention the biggest thing about this project repeatedly is to mention the numbers. You don't want to just... Here's the bad answer on this one. It looks like males break bones more often than females. Well, yeah, I mean, that's what we're kind of alluding to here. It's not that all males break bone or all females don't break bones, but typically speaking, males are more likely to break bones than females. That is kind of the overall what we learned from this graphic. But we need to be like, 59.17% of females have not broken a bone, whereas 40.83% of females have broken a bone. 41.97% of males have not broken a bone, as opposed to 58.03% of males have broken a bone. We can go ahead and subtract these differences and find. So if we go over here and we take if you notice, I'm just subtracting the differences. That the differences between males and females breaking bones is 17.2%, which seems to be a pretty sizable difference in the probability of males and females breaking bones. Does that, for the people wondering about this, does that make more sense on how to interpret this graphic? What's going on? I want to mention again why this is column percentages right here, or rows, excuse me. If you look at where this row is at, what it goes across being the row percentage, it's actually doing for only females. So it's actually a conditional distribution. Given that someone is female, what's the probability they break a bone? So given that someone is male, what's the probability they break a bone? Would be down here. Given they are male, probability of breaking a bone. And that would be for all the males only. If you notice, we have here the marginal distribution of breaking a bone and the marginal distribution of gender. So those are the marginal distributions because they're the distributions in the margin. And these are the conditional distributions because you would set a condition. That's conditional female, that's conditional male. So conditional is when you have to go inside of the one variable. Marginal only looks at one variable itself. Conditional takes one variable and looks at the other variable. So with describing this relationship, is it between females and bone breaking? What I would first do when describing this is I would just kind of read across the females and males. So, and remember, yours is different. I think everyone knows that. But if I were describing this, like if I were to write a statistical report on this, I'd be like, analyzing the variables, we see that females don't break bone. Females who have not broken bones is 59.17%, or, oh my gosh, sorry. 59.17% of females have not broken bones, as opposed to 40.83% of females have broken bones. When we look at the male distribution, for males, 41.97% of males have not broken bones, as opposed to 58.03% of males have broken bones. The differences between males and females who have broken bones is 17.2%. This leads me to believe that males are more likely than females to break a bone. So if you notice, I went through all the percentages right there and kind of highlighted the numbers. Be using your numbers throughout the report. This is a data-driven course. We're going to focus in on the numbers, the interpretation, and making sure we kind of know what is being shown in this report. So does that make some more sense? I'm just going to do that right there. It's fun being on camera. You're welcome. Hopefully, I'm glad to give these answers, and thank you for typing those questions in the chat. And type all your answers. Don't worry. I always say when you type it and you can figure out what you know, what you don't know, and you're doing a great job because that's an amazing question, 1,000 points out question right there. And then, Abby, you were asking about question number 5. I'm just going to talk briefly on it again. We'll do another example with side-by-side box plots. Let's do it right here. And then is my 474 person still here? Because I'll see where they're stuck, and we'll see which one they're working on here. So to do side-by-side box plots, we have 2 variables. One will be quantitative because box plots require quantitative data. Let's see if the Tennesseans have more pets. If you notice, the X variable here is categorical and the Y variable here is quantitative. So quantitative variables make box plots, but we can make side-by-side box plots by doing multiple categories. So that's what's going on right here. Box plots are univariate quantitative, but multiple box plots just mean multiple categories. So it looks like the Tennesseans might have more pets. Let's find out. I don't know. And the answer is no. Oh, that's a boring one. Okay. I would stretch this out a little bit. We're going to do a not boring one. I'm using ones I don't know to see if there's anything cool, and I'm not finding cool things. On how to word and describe the data we found. Great question. Let's see right here. Ooh, this is fun. Let's see if people have student loans, what they think about their salaries. Okay, cool. Oh no, it's so similar. Okay, I got one more idea here. It's not fun when it's the same. We already did one that was not interesting. So starting annual salary, and I think we have honors program. I think that will do it. Where's honors program? I thought you used to be able to search this. Honors program. Does anyone see honors program? I thought we asked it. 2 seconds. If I don't find it, I'll do something else. Well, I'll be. There it is. I knew we asked it. Cool. We're going to see if the honors program can explain what someone thinks they'll make. So this is whether or not someone's in the honors program and their starting salary. And here we go. Well, it's not as interesting as we thought it'd be. So when we analyze this data, we're going to make these graphics go away. I thought there would be a difference here, but there's not that much. I keep saying that. I want to do one where we actually get to say something cool, not just this is the same as this. Let's do gender and salary differences. Come on now. Let's find something where there's differences. Let's find something. Starting salary and gender. Let's do this right here. Let's go quantiles. And it's not different. Oh my gosh. I'm striking out everywhere. Last try here. Let's do if someone's in Greek life and how much money they think they'll make. Let's do Greek life and people's starting annual salaries. Let's analyze this. And the answer is it going to be exactly the same? It's the same. Now, I'll go ahead and analyze it, but we're not getting much interesting stuff. It's all right. But one thing I would do here is I would take this, and since that's just blank space, I would expand it out. Since we're going to be copying this image in just a moment here, why not expand out the picture a little bit? I really would have thought that there'd be a difference between people in Greek life and not in Greek life and how much they expect to make when they graduate UT. But both groups show that the 50th percentile of people's expected GPAs is $60,000, meaning that 50% of people expect to make $60,000 or more, irregardless, it doesn't matter, of whether or not they are in Greek life or not. Do you notice how both of the medians are the same? We see a small difference. Someone can tell me for 10,000 points in the chat. What do you notice here between this number and this number? I see a small difference between the whats of both groups. A small difference between the whats of both groups. A small difference between the what of both groups. 25th to 75th. What is that? The medians are identical. I'll still hear you. The medians are identical. The medians are both 60,000, but from here to here and here to here, I see a difference. The IQR is right there. Both of you in the chat, everyone responding gets the points. The IQR are slightly different. The IQR is for the Greek life is only 20,000 as opposed to the IQR for non-Greek life is 25,000. So you can find these mathematically if you want by going here and going 70,000 minus 50,000. And you get 20,000, and the other one is 25,000. So if I were to write that in a report, I would say the IQR for Greek life is 20,000, representing the range of the middle 50% of salaries, going from 50,000 to 70,000. The IQR for non-Greek life is 25,000, representing the middle 50% of data that goes from 45,000 to 70,000. The non-Greek life individuals have a slightly larger spread to their data. IQR is a measure of spread. Median is a measure of center. So great jobs, great answers right there. Does that make some sense? And do we have, let me see which question they're asking about for the other homework. Whenever you get, can you go over number 5 on homework 3? Are there more questions? I might do this question 5, homework 3 right here. Let's see. We'll get to do some fun coding. Coding fun. And feel free. Awesome, Abby. So glad to help out. Thank you, Abby, for those questions right there. And if anyone else has questions, feel free to drop them in the chat. Where did my? Sorry, this is closed. Sorry, working the quiz right there. Let me see. If you have questions, drop your question in the chat, and I will help out. Let me get the question 5. If you have any questions, feel free to ask. I guess one big thing, before I do this question right here, let me see if anyone has anything in the chat. We still have 15 people watching right now, which is awesome. One thing I often worry about is the intros and executive summaries. So really, the biggest things, and I can't stress this enough, when you do your introduction, if I were to look at somebody's introduction, good. The introduction should look, and I say introduction, but it's executive summary. Same thing for this report. It should probably take up about at least that much. It's good right there. Maybe that's when you know you're pretty much on track with it. Would it be better for me to send my project to you to look over tonight? Yeah, I give a quick skim. And so I'll give it a quick skim. If you want me to read specific things, always come to office hours and pull me over and be like, hey, Brian, look at this right here. And I'll jump over and we'll look at it. So you can send me tonight for a quick skim of your project if you like. So that works really well, Ashley. I'll always just give a quick skim. I try to find big things. I look at it for about 30 to 40 seconds. And then I write an email for about another minute. And so I try to do as many as I can to help out everyone and just give as many tips as I can. And usually if I say you're good, it means you have a 95 or higher with turning in for extra credit. So I'm pretty good at being like, you're good, but that doesn't mean you have 100 because I didn't read the whole thing. And I'm sure someone turned in a report one time that they put a bunch of stuff in there that was not on track. And I was like, you're good. And they got like an 80 and they're like, I'll never send it to Brian again. I mainly look at graphics and I look at the executive summary and outro a lot. I read those portions, but then I don't read the whole report because I look for where I see the biggest mistakes usually. You're welcome. Awesome. That's if your executive summary is taken up about this much space, you're doing a great job right there. Is there a video that talks about what you want us to say? Yes, there is a video. There's a video for that. Let's drop it in the chat right here. For anyone watching this right now, probably the best thing to go to is going to be, we want to go here. I want to go to, where is it? Executive summary. And then let's copy the video link. And copy video URL. Let's drop this in the chat. Yeah, now I'm going to see if it goes to there. Oh no! I've just destroyed the chat. I can't even get back. All right, I'll fix it. But yeah, that's got it right there. Let me do pop-out chat again. Thank you everyone for being here. Let me fix my screen. There we go. And so that should bring you to the video right here. Open in a new tab. Does that link work for anybody or no? Let me try it again. All right. I don't know if that link was working. Let me retract that message. Remove message. Probably not tomorrow. Because I'll teach until it worked. Okay, that one should work too then. Tomorrow I'll be teaching till about 5:30 and I get here a little bit early. So usually by then I'm pretty like my mind's fried and I go home and answer emails. But I will be there from 10 to 12:30 tomorrow. And you can send me your project for me to look over. When you come to office, just be like, hey, Brian, I have a question. And I'll be like, boom, you're next. I always try to, when people walk in, work with them first. And sometimes some people might walk in and I might miss them, but just be like, hey, Brian, I have a question. And I'll go right to you. I think many people have come to my office. Has anyone come to my office and been like, hey, Brian, I have a question. I go right to you. I would just really hate, because I've seen it like one time in my review there, someone was like, I went to his office and he ignored me. And I was like, no, it's never my intent. It was like one review one time and it made me feel very bad. So a lot of times you might hear me say in my office, I might say like, hey, if you need a question, just be like, hey, Brian. Then 3 people will be like, hey, Brian. I'll be like, okay, let's do this. So, and I thank everyone for coming to office hours. It helps like learn the material and I enjoy it so much. I had office hours this morning from 10 a.m. to 2 and it just went like that. Went to Stat Lab, came here, boom. So it's only 1 cup of coffee today. Got to get that second cup. So let's see. We had some chapter or people were working on the homework, conditions and functions. If you have a question, feel free to ask. Someone wanted me to do an example here. We're going to download the data. Let's get the data going. Okay, we're going to open our studio. So 201, close your ears. Be like, I don't want to know. So, we're going to scroll down here. You can watch, of course. But feel free to ask a question. I'm going to talk a little bit. What should I do if I can't figure out how to show the label by value to work in my bar chart? Jillian, let's answer that real quick right here. Jillian, I want you to try this along with me right now. Do I have jump 15 on this? Let me look at my jump version. JMP. I'm on 14. Okay. So watch as I do this, Jillian, and follow along. You ready? We're going to go to Graph, and we're going to go to Graph Builder. I know this is not exactly what the video does, but I figured out what the problem is. I figured it out literally today. Go to Graph Builder. Inside of Graph Builder, I want you to take and I want you to drag the variable you want onto, sure, let's do distance from campus. It's got more variables. I want you to take and drop it into the middle. So we're just going to drop that into the middle right here. So we just dropped it into the middle. Then we're going to click the bar chart, which the bar chart is going to be this one right here, and we just got a bar chart. Now here's what I want you to do. Go to Summary and go to N. Then go to Labels and go to Label by Value. Now what you're going to say to me, Brian, it's not working. And I know, don't worry. I know it worked here. That's the mind-blowing thing. Jillian, are you at this part and did it not work? And I hope the answer is yes, because then I'm going to fix it. Are you at this part right here and it still has not worked? So if anyone is stuck on this, and I might even cut this video, but if you are in Graph Builder and it has not worked, I would now like you to take the same exact variable that you had, like distance from campus, and I want you to hover over these bars. And I don't know if this is going to let me do it on mine because I'm in jump 14, but I want you to hover over, and I wish I had jump 15 on this computer. I might download it afterwards and just make a video showing how to do this, like update on project video. Whoa, getting a lot of cool things. Whoa, he makes so much cool stuff in Graph Builder. But Jillian, when you hover over the bars, do they change colors and the number appears? When you hover over the bars, does it change colors and do the number appears? Like when you take the same variable, I want you to take this variable that you already have on there, and I want you to hover over the bars, do the number, yes. Then go ahead and click done. And Jillian, one more question. Are you using night theme, which has the darker colors? Are you using night theme? Because I think that's where the problem is at. The problem looks to be with night theme for some reason. And I'm going to be writing jump and be like, hey, did you know night theme doesn't show the numbers? Are you using night theme, which will have darker backgrounds on here? It'll look like, just look darker. Because that's where I kept seeing the problem. And if you don't have dark theme, yes, that looks to be the problem. People who aren't using it can do it, and people, it's a good question. Let's see. I don't know. That's a good question. I've never changed my theme on Jump. Customize, menus and toolbars. Does anyone know? But it works now. Yeah, I know, right? I literally, what's so crazy is I just figured this out this morning because I had like 3 students where it worked and 2 students where it didn't. And I was like, okay, what's the difference right here? And that's what we do in statistics. We look at the variation. I have students where it works and students where it doesn't. And you know what we'd literally see? I love this. This is why I love stats. If we were to do something, if we were to collect a variable right here and we were to say works, and then we were to say theme. Now, I had seen some other students where it didn't work. So I'd seen no, 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 no. And then I had students where it worked. I just put the whole link in there. Yes, yes. There. Come on, Jump. You don't know how to copy paste. There. You got to hit it twice. And then we go right here. Awesome. So glad it works. Does anyone know how to change the theme? I'll have to look it up here. But this is what my brain realized, is that if I want to explain why it works, it was actually the theme explaining it. And this is what I was seeing, that it was working. And we can look at this. This is literally like your project. And let's put it on the side like we usually do. Put it nice. And I wish they'd do that. If I could give Jump a suggestion, I'd be like, you should put it side by side. You should do like a minimum output. It should say minimum output. And then, because I just think that looks way better if you're not doing the test. But, so there is the statistical test, because that's why it goes down like that. So when you look at this right here, 100% of the people with the night theme, it doesn't work for. Boom. 100% of the regular theme, it works for. And my brain just started to be like, wait a minute. Every time I see night theme, it's not working. And then I was like, and then like the next person, I was like, wait, are you using night theme? They're like, yeah, it's not working. And I was like, wait a minute here. And then it worked for someone. I was like, wait, you're not using night theme. So I don't know what it is. They must have something coded differently in night theme. Maybe the numbers have the wrong color. Maybe they're there, but we just can't see them. That could be it. I don't know. Good questions. But thank you, everyone. Thank you for isolating that problem. Feel free to ask any question you have. As I look down here, I think they said question 4 or 5. Which one is it? So feel free to ask any question you have. Whatever you get, can you do number 5 on homework 3? Question 5. Oh, leaps. Cool. Right, a function called leaps that takes two arguments, x and lag. So defaults to 1. Okay, cool. Have the function return the vector of x leaps defined as the absolute value of the difference between elements of x separated by lag elements. Okay. So, for example, imagine that we have, these are just numbers. If you're watching for 201, it's just like 5.1, 4.9. See, we could take this code right here, be like, what's going on? Just take the code, copy it down to here, and just run it. And it's just numbers. This is numbers. It's just 5.1, 4.9, 4.7, all those numbers. And if we do lag1, the function will return a vector with elements, 0.2, absolute value of this, 0.2. Okay, so look what it's going to do. It's going to go back one element. It's going to say, if we do lag1, it's going to say, what is the difference between this and this? And then what is the difference between this and this? And then what is the difference between this and this? And what is the difference between this and this? If we were to do lag2, it does lag2 and lag3. But think about this. If we were to do lag2, we'd have to say, what is the difference between 4.7 and 5.1, and we'd get the absolute value of that. And we've actually just kind of heard it right here. We've just kind of heard how to do this. So let's just do some example code right here. We're going to write some example code in here. Okay, example code time. We need to put in a code chunk to do some work. And this is just where we write code, because this is just Word document. If I take this same exact thing and write inside of here, R will get angry because that's a code chunk. That's where you write code like actual computer program. I can try to run this and it'll be like, nope, that's not a code. But you can't run this because this is just a Word document. Well, try to run it, but that's not a Word. That's not where we write code. We write code inside of the R chunks where we write R code. So what do we have right here? We have a vector, and we need to write some sort of thing that's going to do the function for us. So when you think about this, I'm going to call this vector1. So when I do vector1 right here, you'll see something interesting. What I'm running is called vector save into. Just for anyone wondering if my 201 is like, what are you doing? I could do something like Brian, and I could save into Brian 5. Now look over there on the right. Look above my head. You'll see Brian appears and it's 5. I could do Brian and store Brian as Brian. Now Brian is Brian. So vector1 is just something I'm storing. It's just like, okay, vector1 is those numbers. You notice vector is a bunch of numbers. There are 6 different numbers. That's what the 1, 2, 3, 4, 5, 6 stands for. You can see the 6 numbers right there. I've also got something called x right now, which is a different thing to reduce any confusion. I'm going to go here. I'm going to remove everything. Now, the only thing my computer knows is that vector1 is those numbers. The 1:6 represents there are 1 through 6 positions in there. That's what these positional brackets means. The num represents that this is a numeric vector. It's just numbers. If you notice, just for another example, when I do Brian, it's not that Brian itself is a word, but inside of Brian is a word. Now Brian is just this word right here, but I could change Brian to a vector of 5, 5, and look, you can see it, there's 2 positions. So we understand what is going on here, that we're just saving something. We can go here and we can remove Brian. Oh no. Oops, I put a comma, or there we go. Oh no, I'm breaking my code. It's mad at me down there. I'm gonna remove Brian. This will remove Brian from here. Bye-bye, Brian, he's gone. So we're just gonna start from here. Okay, we've got this vector, and now I need to figure out the lag differences. So with these lag differences, I need to take the second element minus the first and get the absolute difference. The third minus the first, get the absolute third minus the second, fourth minus the third, fifth minus the fourth, sixth minus the fifth. So in truth, I need to make let's make a large and a small. Everyone's going to do it my way now. I'm going to make a large, and I'm going to make an end and a start. I'll explain why. Because what I'm really doing is I'm taking this vector here, which is the second number, and I'm subtracting it from this vector here. Because think, 4.9 minus 5.1, those 2 numbers, and this is the first number and second number. 4.9 minus 4.7, it doesn't matter which way we subtract them, we'll do the absolute difference. 4.7 minus 4.6, 4.6 minus 5.0, and 5.0 minus 5.4. So the first number goes to there, and then the second number goes to there, as it starts on the second number and goes to there. So the end vector, or like the end of it, is going to start from the second element and go all the way to the 6th element. And we'll put some coding in here for this. So I can write it the following way. I can do vector, and I can do position 2, 6, or what am I doing? 2:6. There we go. And let's just take a look. Vector's not found because I called it vector 1. I usually like to call it vector. I was going to do multiple vectors. But if you notice here, end, if you look at what it has in it, and let's print it to the screen right now, end has in it the numbers of 4.9, 4.7, 4.6, 5.0, and 5.4 because I started it on the 2nd through 6th position. Look at the similar context over here that these are the positions. And so that's going to give us that. And now I'm going to make a start vector. So pause the video here and think, how's Brian going to make his start vector, the numbers I'm always starting with? Well, I'm just going to copy paste my code. You always want to copy paste when you can. And we're going to do start, and start's going to go from 1 to 5. So that is the vector I'm kind of starting with. And now I'm going to make my lag vector. So my lag vector is going to be the absolute value of end minus start. And always run your code every time you do it. Look at it, see if you got it, what you want. The start vector should be 5.1, 4.9, 4.7, 4.6, 5.0. And that's what we get right there. There's my start vector. And so we just have our start of it, and we have our end of it. I wish I could draw on these screens. One of these days, if anyone knows of any software that just lets you straight draw on the screen, I wish. I think there's things that like freeze your screen. There's a way, and I just wish it would freeze the screen right now, and I could just like draw on it. It'd probably freeze my picture on the screen. So with this right here, we have our end and our start vector, and we have our lag vector. Now, this is going to solve the problem we're currently working on, but 6 really shouldn't be 6. 6 should be a number that tells us the end of the vector. So 6 is going to be the end of the vector. So I want to go to the length of vector 1. Length just tells you how long it is, and that'll go to the last element. So if you notice, that's 6. Now 2 is not really 2. 2 right now is 1 plus 1. It's ridiculous that I wrote 1 plus 1, right? But you'll see why I wrote 1 plus 1 right here in a moment. 2 is 1 plus 1. Right here, this is not really 5. This is 6 minus 1. Reason being is we're going to have to augment these in a moment here. All this code works exactly the same right now because this was 2, and I just changed it to 1 plus 1. This was 5, and I changed it to 6 minus 1. It's still 5. I just wrote it differently. So with this right here written as code, we're going to do something. And before this, we're going to put lag. And guess what lag's going to become? Oh, is anyone in the chat who knows what lag's going to become? I will throw 20,000 points. Is around 800 words a good amount? Probably. Send it over to me and see it, and I'll tell you what I think. Great job, Heidi. And feel free, anyone who has a question right now, 201, ask that question. I've done a lot of good work on this one so far. I haven't turned this into a function, but I'm creating what will become the function. Don't write your function from scratch. Write something that does what you want, and then turn that into a function. So I'm putting in placeholders now so that it will work on any code. So that way I don't have hard-coded in numbers that won't augment. So ask any question if you have it. If you're here for 201, ask a question about the project, and I'll jump to it here in a moment. So be like, hey, Brian, how do you do question number blank? And we'll do it. So we're going to put here lag 1. So with lag 1, guess what? All my code runs because, well, I should have put here lag because that's why I was changing this to 1 because that's the lag. So we're going to put here lag, and that works right there. And now let's make sure our code runs again because we can always Control-Z if we messed it up. And so the lag vector looks like that, and that should be what we're getting. I think it says up here that this is the vector, the 2. See, it says we should get 2, 2, or 0.2, 0.2, 0.1, 0.4, 0.4. Perfect. If lag is 3, the function will return a vector with elements 0.5, 0.1. Well, let's check it. And then, whoops, got to run my last line. And then let's see. I should get 3 elements, 0.5, 0.1, and 0.7. No, don't worry. This is not coding for 201. Someone came in and asked a 474 question, and so I'm working that a little bit right here. And I might leave it at this. This is, if you notice, I've got it working on the example. If 474 is still here, this is a really great start to the 474 question of how do we do it. Other than this, we just have to turn it into a function now. We've written a code that I can input the lag, and I change it, and I would just take all this. I might do this next step. If 474 here, so I can ask a question. Oh, wait, I'm doing 4. We just did 4 loops. So we don't have a FIM function. Now, this, I don't want it to look like this right now, but now I'd put it inside of a function. I'd have someone define the vector. I'd set the lag default to 1. This is technically supposed to be x right here. That would make the vector x. because that's what they're going to input. So everything that was vector 1, and they'll define their vector 1. I got to stop. I don't want to do the whole thing. Let's go to re-indent these lines. But unless I made a big mistake right here, there we go. Make it look nice and pretty. But the lag, I don't want to do the whole thing. I got my step right here. But it's fun. It's fun coding. It's fun when you solve it. This is not done. I think we have some custom warnings on it, but this is pretty far along. We should have some checks in here. So we've got some if checks to see if lag is equal to 1. If lag is not an integer, i.e. lag modulo 1 is not 0, you may assume it will always be a number. The message should say lag should be an integer. So you can put right here, let's just put that in here. Let's do that part. If lag is too big, if it's too much lag, call it. Someone's gonna choose my name. This function is called Brian. This is now a Brian function. There's the Brian function. So we're gonna go here. We're gonna put another argument. We're gonna put lag. If I could spell, still can't spell. Lag equals 1. If this computer got lag, that'd be crazy. It's a really awesome computer. So we have here lag equal to 1, and we're gonna put in a check. If lag, we need to go module. Now let's explain what this code does. I'm gonna explain what this code does here in a half second. I'm gonna write this out. I'm gonna let that evaluate completely. No, wait. I want to put my evaluation right here. If you put things inside of a parentheses, they will evaluate. And then we're going to run the following code. And I'm going to write this myself. It's not what it says to write. I'm going to put message. And I guess, yeah, this is what are you doing? Okay, let's run this. Okay, let's go here and run Brian. And inside of Brian, we'll put 5, and then we'll put that for lag. Oh, it's going to get mad if I do that. So, warning, object longer. Yeah, that's what would happen. There we go. And let's do a warning. Why am I getting my... If this right here, let me check. Oh, okay. I know I did. There we go. Yeah, there we go. Warning message, what are you doing? Okay, got it. So, and then this should have, what are you doing right there? What are you doing? So, this right here, just says, what are you doing? And just, it's a message. And if you're wondering why it wasn't appearing, is because right now, let's show what lag is. So let's take this part out of the code. If you're here from 201, ask a question. I'll get right to it. This code right here, we're just going to evaluate what it does. We're going to go lag, save into, and we're going to call lag 4.4. So what this does when you run lag modulo 1, remember lag is just 4.4. Like you can run lag alone, and that is 4.4. And then we run this right here, and it's the remainder. So is that not equal to 0? The answer is true. So this is not equal to 0 right here. So we have right here that this is true. So when it's true, inside an if function, it runs this code, which is just a message. Warnings appear a little bit differently. There's a message right here, and then it also gives me another error message, all these different things. Warning message, what are you doing? All these things right here. And I guess I might need one more element. We might not get the warning message now. It's still giving me longer. So I guess I need one more. Am I going mad? What are you doing? And this is not completely done yet. I don't have a return on this. If you're watching this 474, I don't have a return inside of this. I think you know where to put the return. It's what you want to return. And I kind of wrote something that we want to get out of this. But that's got that right there. Are there any more questions for 201? Is anyone working on chapter number 6? Got a project question? How are people doing? Who has When you have time, do you mind explaining how to answer 4B and 4C? I'm kind of confused. This 474 is Abby, your 470. Oh, is this project, right? Oh, no, don't worry. This is 201 project, right? I think it's 201 project. Is that correct, Abby? Pretty sure. And don't worry, ask all the questions you have. Awesome. I was just double checking lest it be the 474 work. Okay. So this one right here with 4B and 4C, write a brief description about the relationship between the two areas. Make sure to mention the conditional distributions for both. And then C, use the percentages from your previous decision and talk about the relationship. Let's go back and look at the broken bone graphics right here. And yes, this is the broken bone one. Why is it so taking up half the page? So when you look at this right here, I want you to talk about the conditional distributions. So given somebody is female, what is the probability they do not break a bone? Given somebody is female, what is the probability they do not break a bone? Given somebody is female, the probability they did not break a bone in this data set was what? These are the conditional distributions because when we do conditional distributions, we say given. We say given somebody is female, the probability they did not break a bone is this. And you see, you're only talking about the females, which makes it a condition, as in this is true for the one variable. So we could also do conditional distributions for males, and then it would be condition male. So given somebody is male, what is the probability that they break a bone or don't break a bone? You're right. And that's what you'd want to quote right here. You'd say, given somebody is female, the probability they did not break a bone was 59.17%, as opposed to given someone being female, the probability they broke a bone was 40.83%. The individuals who are male broke bones 58.03% of the time and did not break bones 41.97% of the time. Now, a big thing we can do right here is we can actually subtract these differences. If we want to talk about who's more likely to break a bone, we could go here and we could look at the male versus female percentages, and we could really kind of subtract those and get, I think it was 17.2. So males are more likely to break bones by about 17.2%. You notice how we're using the numbers at all points. Make sure to quote the numbers, quote the conditional distributions, and that's where you'll be getting the points there. Does that help make sense of it, Abby? There's a different example, but uses the Mosaic Plot to help kind of reinforce what's going on right here. You'll also notice as we keep pointing out, yes, that's what I like seeing. Great job. We have here conditional distribution for gender. We have here conditional distribution for broken bone. So you'll notice that there's slightly more females than males, slightly more. And breaking a bone is almost 50-50. Breaking a bone for everybody, about 50% of people, that's for everybody. And you could actually figure it out mathematically if you wanted, because you see there's the breaking bone, and here's the slightly more females, but breaking bone is pretty tied, where male-female, there's a little bit more females than male. That's excellent. Great job. Who has another question about 474 or the project? Some pretty good help for that lag one in 474. It's not done, but should kickstart your work on it. Should hopefully help you get a good kind of ball rolling for that problem, which is what I like to do. So if you're in here from 474, be like, hey, Brian, how do I do this one right here? Always trying to get the ball rolling on those questions for you to help out. And if you want, hit like on the video. We are a public video. We haven't had people come in this semester and be like being random and crazy, which is good. We like a good kind of helping out, but hit like if you want. You don't have to. Someone's watching this in the future like, man, Brian, come on. But what other questions are there? If you have a question, put it in the chat. I'm trying to think. We've done a lot of the project today. Oh, thank you so much. That's so awesome. We're hopefully going to make our channel monetized, and not monetize like every video, but we'd monetize like some of the more helpy videos that maybe go out to a general public. And then I want to just use the money for like tutoring and pizza parties. Like that'd be awesome. I've said that multiple times. We're going to have more meetings about it, and because it's like I have to get it cleared and everything to get it monetized. But that'd be awesome if we were to get a little bit of money and then be like, okay, we're going to have a end of semester pizza party for Stat 201, or, you know, like pre-test pizza party, like come out to study night for Stat 201. I know. Oh man. Anna knows exactly if, oh man, I don't know if the university would let me do that, but I always want that. I want the Red Bull sponsorship. Exactly. Anna, so good to have you here too. I want that Red Bull sponsorship. I want the Red Bull like to be like, just It would be bad. I'd be drinking 3 Red Bulls a day. I've tried to switch to coffee this semester. I've been drinking a lot more. Like I get up, I make 1 or 2 cups of coffee, and then I've been trying to, because I realized, I was like, wow, I'm buying like a Red Bull every day. So I was like, that's expensive. And I was like, I have coffee at home. So I've been doing a good job at that, getting up, making my coffee. And I will say this is my last little rant. I think it's because my classes aren't as early. So usually I get up and relax and like make coffee and stuff like that. So it's a little bit easier. I think last semester I had some 8 a.m.s, and at that point I'm just running out the door. So yeah. But are there any additional questions? 8 a.m.s. Why does 8 a.m. even exist? I know it's yeah. I've got right now. I've got pumpkin spice creamer. I was like, it's the end of the season. Gotta go pumpkin spice. So then I'm gonna go to Starbucks. They probably don't have it anymore. Good, because I'd buy it if they did. So any other questions? And so good to have everybody. Thank you so much. I'm hoping probably next week might be pretty big, because next week we're going to have the test. So this right here is a help video for many of the project questions. It's still raining cats and dogs. If it is, I've got my umbrella now. I didn't this morning, but I've got it now. As I hit the microphone. Really helpful videos for the project. Great job. And tomorrow is going to be a really big lecture. And there you go. I'm glad it's helping out, Abby. Tomorrow we're starting chapter 7. Anna, do you have any advice for the students about regression? They're about to do regression. Is that a pretty big chapter? Regression is such a big chapter. And if you're in the video right now and you're like, why isn't he solving any problems? You can just say, Brian, can you do this problem? And I'll start working on a problem. I just don't want someone to be here right now and be like, we're not doing any work. Because I think we're winding down. We'll see if Anna has any advice she wants to share. Be like, Chapter 7 is not the easiest of chapters. It's not the hardest. The hardest chapters on this test are chapters 5 and 7. Those are the hard ones. So don't miss tomorrow's lecture if you're in my class. Don't miss it. It'll be a big one. And I think I'll wait for Anna to give some advice right here. But does anyone have any last questions? 47421. Oh man, just watch the video and taking great notes is key. Yes, Anna, you're awesome. Thank you so much. Hi, can you help explain how to get the data for project into R? Yes. Catherine, you're emailing me about this, right? I do remember now. Okay, let's do that. Yep, here we go. Let's get the data into R. So here's what we're going to have to do. We're going to have to go over to Jump, and we're going to take the Jump data, and we're going to go here to File, Save As. If at any point you feel like you're spending too much time doing this, don't do it in R. So at any point, if you feel like you're just putting way too much effort into this, don't do it in R. I'm going to repeat that. If you're spending 3, 4, 5 hours and you're just not making any progress on it, don't do it in R. So what we're going to do is we're going to go to File, Save As, and we can already save as a CSV. So we're going to save the file from Jump. We're going to export as are you on a Mac or a PC, Catherine? Are you on a Mac or a PC? If you're on a PC, it's awesome. If you're on a Mac, then I'll have to ask what you see. Okay. When you go do this, I'm going to save mine right here. And don't worry, it's going to open up inside of Excel. When you go to File, Export, I want you on your Mac to go to File and Export. I don't have the Export button because the PC doesn't, but I want you to go to File, Export. And does it have a CSV or does it just say Excel on yours? Does it have CSV or does it just say Excel? Which one does it say? When you go to File, Export, it will say Excel, but does it also have CSV? Is there a CSV option? I've got my Mac on here if I need to double check. But you can save as Excel, and I'll do that. But it'll be File, Export, and then so does it? Let's see. We'll have Catherine confirm here if it has the CSV option. We'll find out. And we're under File and Export on a Mac, which I don't have those buttons. I don't have. Oh, wait. So Okay, wait. If you don't have Jump, 2 seconds. I think I can do this. Watch this. Okay, give me a second here. Catherine, I can get this to you. So we're going to do this the easy way. You ready for this? We're going to do it the super easy way. One moment, Catherine. Let me send you this. What I'm going to do is I'm going to make the file and I'll send you it. There we go. I just found your email. I'm going to send it in a reply to this email here. So just a moment. I'm not in the chat right now, so I mean I am, but I'm not watching it. I'm going to go download the project data, which I already have. I'm going to go here. If anyone's watching this, this is not something you'll do for the project. I'm going to go here to project 1 haircut data. Got the project data open. I'm going to go file save as. I'm going to go to CSV file. I'm fine. Save as another format. Good. So it should open up the data here. Don't show again. Okay, now I'm going to go send you the file. Okay, let me send you the file in a reply right here. I think this is it. Okay. So Catherine, look to your emails now. So Catherine, go to your emails and you should see the data. So go ahead, check your email, see if you see the data in your email, and you should have it. So, and then I'll explain what to do. So do you see the data in your email? And if you have R, you should be good to go on this. Got it. Awesome. Download that file. Make sure it's in your files wherever you're working from. And then we're going to put it into your downloads wherever you're working from. And we're going to open a new R script. We can call this stat201 project. I might not like that dash. This computer's being weird today. Stat201. Stat201 project 1. There we go. I'm going to knit to Word, and I can show you again where I clicked for all this, and here's my document. Just as the data was created and all this good stuff right here, we can worry about editing the rest of this in Word later. I'm going to delete everything from there down. My document's going to look like this. So tell me where you're at. Do you have an open RMD file? Do you have a currently open RMD file? Do you have a kind of file like I have right here? I can re-walk through this process of how to get a semi-blank RMD file. Yes, okay, good. This is where you're going to write. This is where you're going to write your executive summary. So you can just put a spot right here for executive summary. We'll put that in later. And now we need to take a random sample right here. Go here to insert an R chunk. This is where you do the code. I don't know where you're at with R. How much have you used R? Like next to never, some, a good bit, a lot, all the time. Like where would you be at on using R? Like where would you say you're at on using R? It's because you can be like, I know that. Or you'll be like, whoa, wait, slow down. So if we want to take a random sample right here, first we need to load in our data. Got to load in the data. So let's put this, let's call load in data. I'm naming this chunk a lot. Oh, that's so awesome. Cool. So you probably know I'm naming the chunk then. Like, just slow me down if I say something you don't know. Like, I'm just naming that chunk for when I navigate through here. Like, I can see that's just knit options for when it knits. And then I name the chunk loading in data because I could be, like I can be all the way down here and I could click and go to my setup, or I could click and go to this. It's really so awesome. But we're going to load in the data. So we need to go here and we need to do read.csv. And what did I call that CSV file? I think it was like project 1. The best way to do it is project 1-haircut data. Okay. Let's hope I have it in the right file. Project D1 dash. Let's see. Nope, it's not in the right place. Where am I at? Where is R at on this computer? R is... Where is this? That looks like documents. Okay, so that's under documents. So file, save as, documents, save. Yeah, that's my documents. Okay, cool. I didn't have the file in the right spot. This won't actually load it. It's just going to read it. So I have confirmed that I have the file in the right spot. If you notice when I ran the code earlier, it didn't run because it couldn't see the file because I'm in the wrong spot. So I saved my file to the right directory. You can just look at the previous code. The previous code did not run because it said, hey, there's no file there. And I was like, okay, I'll put the file in the right spot for you. Do I need to worry about making my data? Yeah, we'll do that next. Yeah, let's do that. So we're going to store this data as, we'll just call it project data, whatever we want to call it. So we're just, putting it to that object in the environment. If you want, you can clear your global environment just so you know what you're working with. There we go. That's loading in the data. We could say load data and random sample. And to take a random sample, we're going to do the following. We want, let's go to here to sample, and we're going to sample the numbers 1 through 232, and then we're going to take, mine, let's say, is 180 or 179, doesn't matter. If you notice here, these are random numbers right here. So these are random numbers from 1 to 232 and 180. So it's just taking random numbers. If you look at the list of random numbers I'm generating, it's always just a random set of numbers. And so we're just taking random numbers right here. So you could say this as an object and say random rows, because what we're going to do is we're going to go to the project data. Let's do this sample data. And we're going to take the project data. Doesn't matter if we capitalize when we got autocomplete. And we're going to take the random rows, and we're going to take all the columns. And there we go. If you notice right above, I've now taken a random sample of 180, and I have the full data frame. Well, I have all the variables. But that is how you do 100 plus the last two of your UTID. Right here, we now have our random sample. And yeah, that's awesome. We can make our, oh, you know what we're going to do? I'm going to have so much fun with this. Let's go back, and let's go here, and let's go to ggplot to, oh, can we can't use Plotly. It's a bummer. So here is bar charts, and those don't look pretty. Random all state guy. And okay, I like that one. Let's grab this one. So if you've used ggplot, ggplot is one of my favorite packages. Problem is this one might, I don't know if I put ggplot on here lately. I think I did actually. Yeah, I did put ggplot on here. So there's my random sample. I'm going to put another code chunk in here. I'm going to go to insert R. Let's call this bar and pie chart. And we're going to drop this code in. We're going to look how it works. We're saving into object P the ggplot function, which means if I'm using ggplot, I need to go to library ggplot2. And what we have right here is the data frame it's using. The data frame we are going to use is my sampled data. And then we have the aesthetic. Now we do have a bit of an issue. Let's think about this. What we have right here is the way their data looks is they're looking at different lenses and the dose, and I think their data frame is set up different. I might have an issue with this code. So hopefully I'm not going too quick, but I love making plots. Okay, their data frame right here looks like the following. Are they using this data frame? No, they're gonna, okay, but I might use the empty cars. Yeah, let's do it. Let's use this one. It's set up more like mine, so it's gonna work easier when we do this right here. So I'm gonna take this, and I'm using sample data. The first argument is the data you're using. The variable here is the X variable. So inside of sample data, I want day. And this might work as is. Let's cross our fingers. And oops, library. Requires X to be continuous. What's it mad about? Day is categorical. It's saying X as factor. Can it not do day as a factor? Stat bins requires, so it's mad about stat bin. The geom bar. Will geom bar work without stat bin? I think I dealt with this one time. That worked. For the pivot chart, cool, Jillian, we'll go back. For the pivot chart, do you need to add the table we made? Great question. I've got my pivot chart still up. Great question, Jillian. This right here, don't include that over there. This right here is everything. Jillian, does that help out with that right there? If you notice, the table we made just has the same values. So since we already have the values in our pivot chart, we don't need to include the same table. Think about this. We already have the values, so we're good. Jillian, 1,000 points. Great question. And if you have a question, if you're watching the video right now, just throw that question in. We're just kind of doing some cool jump stuff because I mean, not jump, we're doing R. I love coding. If you notice, we got a problem, though. Catherine, do you see the problem with the days of the week right here with this graphic? I'm going to do something right here. Do you see the problem? And I'm going to have to fix it here. This is the fun of fixing stuff. And I will say this. We're not. If you do this in R, you're learning advanced skills, and we're not looking for perfection. I mean, I still want it to be a really good written report, but I'm not like, oh, your graphics perfect. I don't want you to spend 10 hours. If it ever becomes too much, be like, I'm just gonna do it in Jump. And this is just someone choosing, obviously, to. I think it's great though, because it'll get you a lot of skills. I've saved the graphic into object P, but there's a problem with it right now. Day has the wrong order. So what I'm gonna do is I'm gonna go to my sample data. And I'm going to go to day. I'm going to overwrite it as a factor. And the factor is going to be the same variable. Now, it's kind of going to do what I want. It's already I think it is a factor already, but this is not going to change my graphic really any. But now let's add in an argument here. So what I'm going to add into my argument right here, and I'm pretty sure is it levels? Yes, there it is. This orders the levels. So I'm going to start with Monday. And then, oh, no. That's so far over. There we go. Now I got to write all the days of the week. I guess I could, there's another way to do it that might be faster. I could order the levels vector. Sure. Might not look, well. Okay. I'm going to misspell a day of the week. Oh, I have a period there, don't I? If I went to the levels vector and ordered it, that'd probably be quicker. Should remember my tricks. And I like Monday, first day of the week. There we go. Fixed it. So we now have the graphic fixed to the way we want it, and we're good. It'll resize to the screen. But that is now the way we want it. I know, right? Really just nice. And if you saw the code, you can see it on the screen right there. You can take a screenshot. But I'm writing an argument that orders the levels. I'm saving this. I'm taking the same exact variable we were using. I'm saving it as a factor. I'm overwriting it over the same variable, and I'm defining my levels. And I probably could have taken the levels variable and just reordered it. I'm going to do it the quick way now, just to show the quick way. So if anyone's from 474 watching, be like, there's a quicker way. We're going to run all chunks above just to wreck the code we did earlier. We can take, and we can see how this is being handled by R right now. We can say the class of this right here. Oh, I deleted too much. It is a factor. That's good. So what I could do is I could go to the levels vector of this, and the levels vector looks like that. And I could go and I could overwrite the levels vector of this with the levels vector. I'm going to take the same exact thing, and I'm going to go to the levels vector, and I'm going to pull from it positions 2. Didn't do the right thing. 2, comma. Could be on the screen. 2, comma 6, comma. Gotta see where Wednesday's at. 7, comma. I'm gonna say 8. 5, comma 1, comma 3, comma 4. Okay, I think I did it. Okay, now if you look at the levels vector now, I just overwrote the levels vector with the order I want. So it's the same. What I have on line 24 and 25, I wouldn't put both those in here. But line 24 went to the levels vector of the factor and overwrote the levels vector because it was already a factor. So I just redefined the levels vector. And line 25 saved into a factor, but then defined the levels afterwards. So it was a new argument to define it. So there's always 2 ways to do things in code. Well, 2 ways. What am I saying? There's a billion ways to do things in code. But line 24 might be more concise. It's already a factor, so let's just reorder the levels. But I will say this. If you were to run this code a second time, it's probably going to jumble them all up. I think it's a bad idea. Oh, no! So in truth, the safe way is line 25 because that's going to fix it. So we'll go down here and just rerun our previous code. One of the coolest things, I don't know if you know about this package, but we have something called Plotly. Do you know of Plotly? That's why I saved that as an object P, because if I have library Plotly on here, which I should have, Oh no, we need to install Plotly. Never install up here in your R documents because you'll forget about it and you'll try to knit it and it won't work. Plotly, most amazing package there is. So let's just wait and let Plotly install right here. The reason I saved it as an object P is because I'm going to manipulate that object. And that's what they choose. It's the graphic, what they call your graphic usually. So we're going to go right here and we're going to load library Plotly. This does nothing other than load up your functions and everything else, functions, data, whatever's in that package. So you're not actually doing anything. Plotly's awesome because guess what? ggplotly is inside of here. And if you go ggplotly and run this, guess what? It turns this into a Plotly graphic, and we can now hover over it, and it'll give us all the things. So it's kind of like a pivot chart almost. It's got everything in there. I wonder if, can we add the counts to these? Because that would be nice. But it does it when you hover, and you can take screenshots of it. You could, but this right here, if you knit as an HTML, knit as HTML, sure, let's call it random. When we knit this as HTML, it'll actually put a graphic in the HTML that we can use. So this is now, it should, are we not doing ggplotly? Oh no, where's my hover? Well, that's sad. Open in browser. Cool. Oh, really? Oh, wait. Oh, you might understand. If anyone's watching there, will know Brian. I did that down in the console. Oh, wait, there's ggplotly. Let's remove this P right here. And ggplotly should display it. Let's run it again, knit it again. Where's my knit button? Here's the knit button. Knit to HTML, let's see if it does it. And the answer is, there's the graphic and there's the hover. So you could literally put this on the web right now. And if you notice there, I had both graphics displaying. I'd probably delete all this output right here. Like, I don't need to know. Those are warnings or those are messages. So you can change and suppress messages. So in your report, don't include stuff like this. You can delete it out of the Word document. But you could put this on the web and literally, so many sites have graphics like this now when you hover over. And yeah, you're making a graphic just like those sites where you hover over it and it tells you the amount for each one. So very easy to use, very easy to create. All you do is make a ggplot graphic and put it inside a ggplotly, and that turns it into a Plotly graphic. So they kind of merge the two so that you can get the power of Plotly by just making ggplot graphics. You literally just store a ggplot object and then put it in ggplotly. So that's why I stored it in that object instead of like wrapping it around new code. Catherine, does that help out with this? We could look at a pie chart right here too. Just do that one. I saw your question and then I lost it. Is that what you want on the report? You have my permission too. If you want to turn in an HTML, you can. If you're turning, and once again, do not spend like 20 hours working on this. You can instantaneously be like, Brian, I'm just going to do it and jump. But I do think there's a lot of learning here. I think there's a lot of things that you can find out and get better at and have coding skills. Practicing coding is always a benefit to getting your skills up. And that's what we want to do, especially with this. But for 201, like the general purpose 201, coding would be way too much. Like we don't want to be like, hey, you're going to be coding. It'd be too much to everyone coding, and not everyone will code. You'll answer all the questions just like you would, but then everything else can be done via, coding. And let's go here. Let's go to ggplotly. Let's do a ggplotly pie chart. Ooh, Tableau. Add from Tableau. Tableau is like, you want to make graphics? Tableau's trying to get our money. No, we're giving it to Plotly. So here we go. Oh, look at that. This is so awesome. See, they're already... How's it doing that? That's not a ggplotly yet. Oh, it's Plotly already. Well, wow. It's an amazing graphic. Are they taking the data from somewhere? If you notice, they're doing data. They've already got the data stored. And, well, I'll be... They're doing x-axis, is this, zero line. I don't know what all those arguments mean. They've got a title, labels minus categoria. That's probably the category is right there, row names. Okay, values, type equals pi. Oh my gosh, can I just change it to a bar? Can I take this data? Does it work? I have so much fun with this stuff. Let's see if this works, because a lot of times they'll post stuff you can just run. So I'm just going to, sure, we got to do it inside here. We're just going to put their data inside of here and see if it runs. And then I'm wondering if I can just change that to pi because that's a game changer. I'm going to decrease font size. Sorry. View, zoom out. It's just getting, I can't see the whole. I like my code not to wrap around the screen. Okay. And there. Let's view, zoom out one more time. Okay. It's so small now. Okay. Does this load? Does this load? Oh my, it does. Probably data set inside of R. And it looks a little bit weird because of the way it's kind of crunched in there. So obviously when we knit this, it'll look better. So we'll worry about that here in a moment. Data frame, let me look at the data frame right here. We're storing it in there, US expenditures. I want to see what this data looks like. And if you have a question, feel free to ask. So if anyone came in here and they're like, what are you doing? So this right here is taking, it's already a table. So they've stored a contingency table, and then they're only taking, so they're taking categories equals to US expenditures. Oh, and they're turning it into data frame, row names, US expenditures. So then let me do this. Let me go back. It's already that. Is that something already saved into R? It is. It's already in there. And they're taking, and let me look at this. They're overwriting it. And they're making it, and then they got the categories. So what changed about this? They just added a category. They really didn't change it much. Sorry, this is the most interesting stream I've ever done right now. I'm like, okay, then they're storing it as data right here. And then the data they're working with, this is where they're making their table. The data they're working with looks like what? It's just got the two variables. It's got, so the Y values is the values that go into the pie chart. And did they store it as percentages? No, they didn't because those aren't percentages. Because it can't be 86 and 46%. And then they have the categories is going to be the variable that we're going to display as we hover over these. And then the data is the name of the data frame. So we have to turn what we have into a table. Okay, so that's how it would have to be run right here. So it's going to take a table and then do this. And this is a piping option right here. It's going to pipe it into the layout. Okay, so we have to make our data look the same way to make it look awesome right here. So Catherine, I'm hopefully going to give you some key tips on how to do this because these graphics will look great and then you'll get some more skill with coding, which is awesome. But if you just make a normal pie chart, that's cool too, but why not go all out? Why not make amazing graphics? Because when you see people making these interactive graphics online, you're like, how do they do it? We just made an interactive graphic. We can hover over it and it shows you everything. This has, if we put it to the proper layout, you can hover over this and it's got all the categories. You can even remove the categories on the pie chart, just so people can see what I'm doing, which you really couldn't see there. But on this pie chart right now, you can remove these categories. You're like, oh, I don't want that category included in here. So you can just remove categories out of here. You can be like, let's only compare these two right here, or let's put this back in. So you can literally remove categories like that. It's so awesome. I know, it's so cool. That's what the power of Plotly is. Plotly takes ggplot objects, and so I'll hover over. You can be like, let's just compare the two largest categories in here. And it's like, okay, the two largest categories make up the following percentage of the data. And it actually gives you the amount of observations. You see there's 46.2 observations there, or that's the amount like in units, and then this right here. So you know what we could do? We can do this pretty easily. Okay, so we're supposed to do day of the week. Okay, so we need to make a table of day of the week. So we need to go table. We have to make our data look like that down there. We have to, or let's point to it. It has to look like that. So sample data, $. Oh, I deleted my data. No. Run all chunks above. Cool. Data's back. I typed the $sign and it didn't appear. And I was like, what is going on? There we go. Okay. There is a table of day of the week. That is just a vector. So now what I want to do here, I'm going to store this as tab. So I call my tables for short. I'm going to take and make a data frame called DF. I call those just my data frames for short. the data frame is going to have in here two vectors. And I want to show you how data frame is made. We're going to choose vector 1, it won't be called vector 1 in a moment, is going to be equal to 2 comma 5. Whoops, wrong button. Vector 2 is equal to 6 comma 7. And now we look at the data frame. It looks just like an Excel spreadsheet. It just has the two vectors in it. So when I write these vectors right here, they're actually going to go down. So every vector I write is actually going down. So the first vector, 2, 5, is in column 1. So what I want in column 1, if you take a look at the first column they're using right here, is the category. So that's actually the name of the day of the week. So what I want for column 1, like their data frame, is I'm going to do day, and I'm going to go equal day. It's going to be called day. Sorry, I was like, where am I? Day equals names of tab. A table is a named vector. So if we look at this, always look at what your code does, because like, what am I running right here? I've just run this enough time to know. I'm hoping this works because I want to make this graphic. If you notice, those are the days of the week: Friday, Monday, Saturday, Sunday. We do have a problem though. We're going to fix the way they're ordered. Oops. Because I didn't run that code. Okay. Now we remake our table and we relook at the names here. The names should be in order. And there we go. Actually, it probably wouldn't matter for the pie. So now we've got it ordered. And in number 2, we're actually going to take and we're going to store here values. So that's just the values. And I'm going to take my table and I'm going to use a function called unname. This is going to unname the vector, and it's just going to give me the numbers in the table. So that what I ran before was the names of the table, and unname. That's the name of the function, unname. And you notice right here, this is just the values. So I'm taking off the names because a table has a names like value to it. So you notice the names of the table at the top, and then when I unnamed it, it took off the names. It's just a numeric vector now. If I say anything too fast or something that doesn't make sense, just tell me. But what I'm thinking with this data frame now is this data frame is going to look a lot like the data frame. What is values var? What did I do there? How did that be? Values var, values freak. When did that appear? Let me rerun it. That's confusing. Let me do this. RMDF, remove the data table. Let me do this. And whoa. It's bringing in something. Values variable 1, values free. Oh, it must be when you copy a table. Okay. Well, we can fix that. Let's fix that here. Let's go df, store into df, remove column 2. If you notice that just removed column 2, this is the column space right here. I don't want that column 2. Names df, this pulls up the names of the data frame. Store into names df, the vector, that needs to be a vector. Store into names day, comma, values. Cool. Now we look at it right here, and we should have it fixed up, and we got it. I could have ran it either way, but I just like my stuff to look like it should. I want it to look the right way. So, and once again, you can always pause this video, go back. I know I'm doing things quickly, but just correcting it as we go. The whole point of this was to make it look just like the data right here. They're using this data right here. This is their data with the categories and the X1960. And actually, they've got the row names equal to this. So I'm going to make it look identical. So what we need to do is we need to go to the row names of DF. So we're going to the row names of DF, and we're going to overwrite the row names of DF with the vector inside of data frame $day. Oh, I had it right. And if you look at this, let's look at their data again. Here is their data, which has the row names equal to the categories with a variable right here. And when we look at my data, now, if you want to know something funny, here's what we could do that's really funny. I bet I could make this work. Well, okay, let's do it this way. Let's do it this way first. And if I don't get it to work, I'm going to do it the funny way. Because I'm just going to name my stuff their names and just use their format. This needs to be the name of our data frame. You see theirs was called data, mine's called df. The labels, they've got called categories. So that is the name. If you look where it is, that's day. That's just the first thing right here. So mine is called day. The values, if you notice, their values are in X1960. My values are in values, because I like calling it what it is. And then you know where to find it. Is it properly spelled? Oh, did I do a lowercase? I guess I did. No, I did an uppercase. It's looking to the global environment. That would have changed it. Be careful, autocomplete can trick you. Let's do this. There we go. And I think, let's cross our fingers. This is the moment of truth right here. Okay. Oh, and I have to display it. Boom. Got it. Here it is. There's the daily business at our salon. We've got the numbers on the pie chart, and we could even compare days. Like, we could compare, what is our best day? Our best day right here is Saturday makes up 23% of the business, and we have our worst day is Sunday, and you could literally do a comparison metric between Saturday and Sunday to be like, okay, Sunday, there's Saturday to Sunday right there. Saturday to Sunday differences are being compared, and we've got this graphic right here. And this is why I support using programs like this or using R, because I can put this in a web page now. Everything's hoverable, nice and easy to read graphic. Didn't take that long to make. And I'm wondering, I've got a big question in my head right now, that if I change this one thing to not be pi but be bar, it ran. Oh no, we see so many errors on the screen. Is it loading or did it crash? It looks like it doesn't like the pi for that. I mean, the bar for that. It's a warning message. Bar chart. Oh, wait, here's the options for it. Trace must be one of the following. Oh, wait, but we did that. We did bar. Is it going to give the same message here? Okay, now it's mad at this. That's why when you change things, things go nuts. Bar objects don't have these attributes. Labels, values. Okay, so it doesn't have labels or values. Why not? Labels, values, really? Well, that's no fun. Let's see if they have it on their screen still. So there's that one. Oh my gosh, look at how beautiful that is. Whoa, triple pie charts. I mean, pie charts aren't the best, but that's still kind of cool. Ring chart. I like the way this one looks. And does ours not say the words inside of it like this one? Oh, can we do that? So is this the same data frame? Really? If it's the same data frame, we're good to go. And you know what I was going to do? Yeah, we should be... I'm going to do the trick now. I said I was going to do a trick for this. But if you notice the way this is coded... I'm just going to make my data look like theirs. So what I'm going to do is instead of calling this, when I'm finished with it, I'm just going to store it into DF. So I'm going to basically make my data frame look like theirs, which I've already done. And then I'm going to call my variables the same. So the name of their first variable is category. So we're going to call this category. So we got to make sure we spell it correctly. Good. And then this is X190. Okay. It's not going to say the right things. That's a capital X, 190. This is the quickest way to see if it works. It's just not going to say the right things in here. I think that's going to do it. And then, so we're going to run this. Everything's running, good. Then last but not least, I'm going to call this... I'm going to take the data and back it up just in case, so that way I can look at it again, just be like, oh, what went wrong? And now we're going to take data and overwrite it with df. Cool. So now, when I run this, what happens? The answer is I get my data. And actually, it worked perfectly fine. All I need to do is just change this title right here to... and we should be able to run it from there. Yep. There we go. Here's our daily business at our salon. And I guess it doesn't have the option thing on it anymore. They removed that. Oh, it's saying $33 billion. We're just making so much money right now. But we obviously need to change those around, and maybe we want the other options back. But this is not perfect yet, but just kind of shows you how you can kind of drag and drop and take what someone has. Oh, look, it takes the Ooh, I like this. So, whoa. So wait. Paste. Look at this right here. When you hover over it now, it's going to say 33 customers, 29 customers, 28. You get hover over and you have everything. Amazing. Well, I think, when does Homer 4 release? I hope soon, Connor. I hope soon. And Connor, if you didn't see, we're doing some really cool like ggplot, Plotly stuff here. But if you look at how we're pasting in kind of the stuff, kind of some cool stuff to end right here with pasting in what all this will be. And so that's going to probably do it right now. I'm going to run and get some food, but we should have homework for release soon. I know we've extended. Ah, no, I broke it. What did I do? But that's kind of got it right now. Does that all make sense to everybody right here? What we have going on, this website cannot be reached. That's weird. 29, 32, 29 customers. It was just one of my students wants to do Stat 201 with R, and I said, you can if you want. And this is ggplotly. But that's got it. Hopefully we're releasing Homer 4 soon, so I'm going to get a head start on it. But this is ggplotly, and I kind of tricked it. I took their code and just overwrote their data frame with mine. But it's really cool. The pie chart, really awesome. We can see how many customers we have by hovering over. And if you go to knit, we should be able to knit to HTML, as long as I don't have any typos in here. And now if you see, we open in browser, and we've got this bar chart right here, and we've got this pie chart right here. So, and it literally says how many customers there are. So we're making these interactive graphics right here where someone can just go to our data and be like, oh, cool, look at this right here. Look at the amount of people we have on each day. And then also right now the text literally says on there 35 customers, which make up 19.4% of our business. So this is kind of, I'd love to do a class. Catherine, awesome. Remember, you don't need to go this crazy. I will literally accept a bar and pie chart, but I like making fun graphics. So that's kind of the start of it right here. Don't go crazy. But make sure you do everything and make sure you analyze everything. Also, Catherine, I've got a really easy way to make a Mosaic plot. The Mosaic plot, I'll show you that. Here, let's do it. The Mosaic plot, and Connor will know this. You need library reg class. And actually, you can do question 4 and 5, I think, with this. So you need to go to library reg class, which you'll have to download, and you want to see, where's the name of my data? Sample data. Sample data right here. I want to see if someone's payment method. So I'm going to do the following. Attach. Cool. That gives me access to the variables. And then I'm going to see payment method is explained by married. And then, actually, you know what? That'll probably run. It does. And if we look right here, we can see the graphic for it. And we can see the percent of people who pay. So that's all the code you have to write to run this inside of R right here. Is if you have reg class, which is the regression class we teach, you can see that the people who are married are vastly paying with their card, and the people who are not married are not. And so all I did was do the association between payment method and whether or not someone's married. Since I attached it, I didn't have to call the data frame. And I know it's so quick, it's so easy, I love it. We're going to put payment method over here, and we're going to do tip amount. And guess what we get here? Side-by-side box plots. You also have all the analysis right here, but for all the hard work we did on the earlier ones, we now have quick and easy analysis. And look at what we have down here. We actually can compare the medians between the groups, and we can compare the means. You notice both these differences right here are unlikely due to random chance. Between the means, there's a right skew to this. You see some QQ plots for normality behind my head right here, and we've done almost the whole project, which it took us so long on those bars and pies because if you're going to make fun things, you want to make a histogram? Here's how you make a histogram. It's hist. So, man, but okay. I was about to use such long code to get this. Yeah, no, this one, that's why I wanted to show you such an easy way to get it, because you can get all the graphics right here to do the statistical tests on it and get all the histograms. And the quickest way to get tips is this right here. I know Connor is so right. Check out those departures from normality, craziness. But red class is so awesome. It's major departures from normality, especially here at the top with the extreme tips. And this one has really bad departures from normality on the QQ normality plot. And you can always do a QQ plot on it, the full thing, if you really want. You go here and type QQ and put in tip amount, and you can see that we see some major departures from normality on here. That's what the normal is, and we see a lot of high-end departures. GGB swarm package, what is that? Connor, explain, what is GGB swarm? We're going to get it. This is us just having some fun in this video. What is this? It was built, because I've got the old version of R. Need to update R again. I don't use R all the time on this computer. GGB swarm. What does it do? Is it a function that I just run? Geom. It don't do anything. What is? You'll have to send me some code with this, Connor. I'm sure it does. I know it does something. You can layer a box plot on top of. Wait, what? Oh my gosh! You should send me code with it. You should send me code. Yeah, awesome. And Catherine, just keep working on the project. Send me a question. It's a point data. Do you have some code written with it? Like, send it to me later tonight. I'm probably gonna go eat some lunch now. But send me some code, because every GG package is awesome. Yes, thank you so much. It's students who told me about GG Plotly. It's students who called me. I mean, I ate breakfast, and so so it's students who told me about all this stuff. It's students who tell me about the new packages and like, hey, check this out, check this out. I didn't know about GG Plotly or GG and Plotly till like 2014, and then students told me. I wasn't even using dplyr much, and the students were like, hey, you should use dplyr, and I started using it, and now I show people how to use it. I learn a lot from you guys and gals, so I really appreciate it. Hopefully we're gonna have a new intro tomorrow, a really exciting one, and I'll have to share it with you, Connor. You'll be super excited. So we'll play the Stat 1 outro now.
Yeah, 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 yeah.